Hi class, I'm sorry that last video cut off so abruptly. I don't know what happened. My computer just froze. So we're gonna move on. I'm gonna repeat that last statement about Heschel's gyrus. Go on and talk about Wernicke's area for a second, and then we are going to move on to the peripheral nervous system. So this is chapter 3, part 2. Heschel's gyrus, the auditory cortex. Heschel's gyrus is where auditory perception and sensation happens. Heschel's gyrus, the auditory cortex, interprets all types of sounds, not just speech sounds, but in the left temporal lobe, it is specializing in speech sounds. In the right, melody, rhythm, and phrasing. And then Wernicke's area. Wernicke's area in the temporal lobe, the left hemisphere. Wernicke's area specializes in comprehension of language. So meaning is assigned now to the stimuli received and processed in the auditory cortex, passed on to Wernicke's area, and we interpret, we have that meaning assigned to the information. So on to the peripheral nervous system. Remember that the peripheral nervous system carries sensory information away to and from, the brain. I'm going to start that sentence over. It carries sensory information to the brain and motor commands away from the brain. So the 12 cranial nerves. This in your book is on page 95, table 3.3, there are 7 of them that are very involved with communication. Again, I am not going to ask you to memorize these, but I do want you to hear them and hear what it is they are involved with. We're only going to talk about these 7. Cranial nerve number 5 is called the trigeminal nerve. It is it is in control of facial sensation and then jaw movement, or concerned with. Cranial nerve number 7 is the facial nerve. So this one is taste sensation and then again movement of facial structures. Cranial nerve number 8 concerns itself with hearing and balance. It's the acoustic nerve. Cranial nerve number 9 is the glossopharyngeal nerve. So that should tell you tongue sensation, palatal and pharyngeal movement. We're going to talk about all of those structures involved in a minute here. Cranial nerve number 10 is the vagus nerve, and it's VAGUS, not like Las Vegas. Vagus nerve. It's involved with taste sensation, palatal and pharyngeal, and laryngeal movement. So it's where our voice is innervated in the larynx. Then cranial nerve number 11 is the spinal accessory nerve. This one is concerned with, again, palatal, pharyngeal, laryngeal, head and shoulder movement. And then number 12 is the hypoglossal, and this is tongue movement again. The remaining 5 are related to smell, visual processing, and eye movement. So again, they're important in communication, but not as significant as the other 7. And again, remember, there are 31 pair of spinal nerves. We're not going to talk about all of these, but they run between the spinal cord and the peripheral areas of the body. These deal with reflexes and with sensory information and then motor activity. So moving on to the specific anatomy and physiology of speech. We're going to be talking about 3 related processes when we talk about speech. We're going to talk about respiration, phonation, and articulation. So starting with respiration, the system of the human body that controls breathing. It's controlled in the brainstem. Typically, breathing is involuntary, right? You're all sitting, listening to me, and you are breathing. You're not thinking about it. It would be terrible if we had to think about it all the time. But breathing can also be very voluntary. I can tell you, take a deep breath, and then you have volitional control over the respiratory system. There are very different sets of muscles that function for inspiration, bringing air in, or expiration of air. There are also different muscles that are engaged in firing for passive breathing, which is what I assume you are all doing right now, or for voluntary breathing. That would be that volitional control. The lower respiratory system is housed in the thorax, or the skeleton of the chest. The diaphragm forms the very bottom of that thoracic cavity. So within the lower respiratory system, sort of from diaphragm up, we're talking about the lungs, which sit within the pleura. The bronchi, one for each lung, by which air enters into the lung, and is then divided into smaller and smaller tubes, which end in alveoli, which are small sacs within the lungs where oxygen from the air and carbon dioxide from the blood are exchanged. Okay, so that's the lower respiratory system. The upper respiratory system, so going from the lungs up, the trachea, which leads from the lungs through the larynx, okay, the larynx being then the next structure of the upper respiratory system, and then into the oral and nasal cavities. So those are our structures, the anatomy of the respiratory system. Respiration for passive breathing. Remember, passive breathing being probably what you're doing right now while you're just listening. It differs from respiration for speech production in three important ways. The first way is that more air is inhaled and exhaled when we're speaking than is for passive breathing. So if you think about it, you, as you're sitting breathing, you're taking shallower breaths, to use a more common term, than I am as a speaker. When you're speaking, you have to take a deeper breath, and then you're expelling more air in that second half of the process. The second difference is there's much greater volitional control for speech respiration than for passive. Even though I'm not sitting here just really thinking about how big a breath do I need to take for that sentence, I do have far more volitional control over my breathing while I'm speaking than you are exercising in passively breathing. As we're speaking, we manipulate both inspiration, or the intake of air, and exhalation in order to best serve the needs of speech production. So just as an example, this is a very different speaking process, the respiration involved in speaking to you through video, than is needed if I were sitting in a lecture room and I have to constantly be thinking about making my voice loud enough for the person at the farthest corner of the room. In that situation, I do have to take deeper breaths as I am speaking in order to have better control over that respiration to control the loudness of my voice. So the third difference between passive breathing and the respiration needed for speaking is the time ratio of inhalation to exhalation in each cycle. So the cycle is the inhalation and then the exhalation of air. In passive respiration, that cycle is about 40% inhalation, 60% exhalation. For speaking, it's more like 10% inhalation and 90% exhalation. I take a quick, deep breath, and then I can talk over that breath for a much longer period of time than it took me to take the breath in. So now onto the structures for phonation. This is the process that takes the energy from the lungs, the breath of air, or the column of air from the lungs. It works on that airflow to convert it to sound, to voice. And that almost all happens right here within the larynx, but some of it happens a little higher up, and that's where we'll start. The pharynx is the mucosa-lined muscular tube that runs from the back of the nasal cavity through the rear of the oral cavity and to the entrance of the larynx and the esophagus. It is the resonation chamber of the voice. This is where we get the richness of tone of our voice. And it can be divided. We could divide it anatomically into three parts. The nasopharynx, just a continuation of the nasal cavity, to the oropharynx, which is what we think of as our throat, not down here, but when the doctor's looking in your mouth with the tongue depressor and the light, he's looking mostly at your oropharynx, your throat. And then into the laryngopharynx, which is a small portion of that muscular tube that opens in the anterior into your larynx and in the posterior to your esophagus, which we don't want involved in the speaking process. So then on to the larynx. The larynx is a cartilaginous, so made of cartilage, sort of box that sits at the front of the neck and on top of the trachea or the windpipe. Its primary function, this is super important, its primary function is not voice. Its primary function is to keep everything but air out of the trachea. So within the larynx are the vocal folds. So they close very tightly to aid in protection of that trachea, but they also vibrate to produce voice. The larynx is suspended from a bone called the hyoid bone, and it's made up of several cartilages that provide its structure and provide the connection point for the laryngeal muscles and ligaments, including the vocal folds. The epiglottis is a special leaf-shaped cartilage whose primary function it is to shield the larynx. So therefore it is also shielding the trachea from penetration by anything but air. Remembering the larynx's primary function is to keep everything but air out of the trachea. The vocal folds stretch horizontally from back to front. They're in the back, they're connected to two little pyramid-shaped cartilages called the arytenoid cartilages. And then in the front, they connect to the hyoid bone, the hyoid cartilage, which is the big kind of shield-shaped cartilage in the front. So voice happens when the vocal folds are set into rapid vibration. The pitch of a voice is determined by the size of the vocal folds and how rapidly they're vibrating. A female vocal fold, on average, the vibration is 240 times per second, or 240 hertz. And in a male, the average is about 130, which is what's accounting for the difference in pitch between a female voice and a male voice. Now, I happen to have a pretty deep voice for a female, so mine is probably below that 240, but certainly not down to 130. The trachea then, this is kind of tricky. The trachea is the cartilaginous tube that runs from the oral cavity down to the lungs. So through the larynx. It's not within the larynx. We don't think of it as a completely separate tube, but the larynx is part of that structure of the trachea, but it goes beyond the bottom of the larynx. Now onto the structures for articulation. So we've covered respiration, phonation, and now articulation. Articulation is the manipulation now of that airflow to create precise speech sounds. So we have this respiration, we phonate it or provide voice to the airflow, and now we are going to move the articulators to make precise sounds. The articulators are the maxilla, the mandible, those are the two big bones of the jaw, the lips, the teeth, the hard and soft palates, and the tongue. So I think that the function of the mandible, which is your lower jaw, the lips, even your teeth and tongue are fairly obvious. But let's talk for a minute about the others. The maxilla, your upper jawbone, does not move, but it is moved against. So we bring our jaws together. We move the lower jaw up against the maxilla, or we move our tongue up toward the maxilla. The front of the hard palate, in the front of your hard palate, there's a really bumpy ridge just behind your top front teeth. That's called the alveolar ridge, and it is the articulation point for t, d, n. So if you each practice those sounds, you'll feel your tongue moving up toward that point to make those sounds. And to some degree also for s, z, sh, ch. You can feel your tongue moving up toward that point. The alveolar ridge, or your hard palate, extends back. Now, the soft palate, if you move the tip of your tongue back along your hard palate, it comes to a point where all of a sudden the bony structure ends, and there is still structure there, but it's soft. You can push your tongue up against it. That's the soft palate, or the velum. The soft palate is the articulation point for sounds like k and g, and the ng sound, ring, the ng sound. Our back of our tongue is moving up and pushing against that soft palate. Also, the soft palate does move to assist in allowing nasal resonation. So the n, and again that ringing sound, those are nasal sounds. The resonation for those sounds is in your nose. So if you all touch your nose while you're saying you can feel the air vibrating through your nose. The soft palate has to move to either give us nasal resonation or oral resonation. It's not a volitional movement. I don't know anybody personally that you can say, okay, I'm going to now move my velum, move the soft palate. But it does move during speech. We do move it in order to control that resonation. A definition that I do want you to know that is not in this chapter. It is in your book. It's actually in the very last chapter of your book on page 505. But the definition is the phrase oral motor function. Oral motor function. When we are measuring oral motor function, what we're doing is looking at the strength and the coordination of all of those articulators. So that's part of our diagnostic process as speech pathologists, is to assess oral motor function in terms of how the articulators can move and perform for speech production. We are going to stop this video right here. This one was much shorter than that first one, and I'm going to try and get better at sorting out these lengths. We only now have left to talk about the structures for hearing and for swallowing. And so I think we will save that for our Zoom meeting. It shouldn't be too long to get through those last structures. So, all right, we'll see you on Zoom.